Hi everyone, Queeveen here from the comfort of my kitchen. Welcome back to part 2 of the 100 subscriber Q&A special. I will hopefully get through a few more of the questions in this video. I'm going to start with the first question, which is what makes an orbit eccentric? And I think this is a great question because in our solar system, a lot of the orbits are minimally eccentric. And the reason for the planet's minimal eccentricity, what keeps the eccentricity going or makes an orbit more eccentric and then less eccentric over time, seems to be the influence of other planets. In our solar system, the planet's eccentricity does vary. We do change how eccentric we are over time. So the Earth's eccentricity will vary. I'm going to start by taking a closer look at Neptune, which has a particularly not eccentric moon going around it, the moon Triton. Neptune isn't visible to the naked eye, so I will need a little bit of help to find it. There it is. Thankfully, it's above the horizon, and I don't have to mess around with the ground or the atmosphere or anything. There's that nice blue color. And there's Triton, huge moon. And its orbit around Neptune is pretty close to circular. It looks a little bit off here, but we're not looking directly at the equator of Neptune. Things are a little bit tilted, but the orbit of Triton is incredibly circular. With a lot of objects in our solar system, things orbit in a pretty circular way. If we take a look far to the Oort cloud, for example, or the Kuiper belt, a lot of things out there orbit pretty uniformly, pretty circularly, but the action of the planets in our solar system like Jupiter and Neptune pulling on those distant objects, disturbing their orbits, that causes them to start falling in towards the sun. So their orbit becomes eccentric because of their interaction with other bodies. But I did mention in the previous video, which tackled some of the earlier questions in the Q&A, this doesn't seem to be the case for planets going around other stars. So here's another quick look at how many other solar systems we've discovered. There is a lot of stars out there with planets. And for a lot of these other solar systems, much more eccentric orbits. So there is a good chance that when the cloud of dust and rock around a small star first starts coalescing together to form planets, the chaotic collisions of the planemetessels, the little balls of rock that eventually smush together to form full-blown planets, or end up stuck as dwarf planets, like Ceres in the asteroid belt potentially. These collisions, these chaotic interactions, cause the fledgling solar system to begin with a lot of eccentricity. There's a good chance. And we're taking a look in here. So there is a protoplanet in there, or a protoplanetary system, or a protoplanetary disk, a proplid. But these early solar systems may in fact begin with a lot of eccentricity. So the interaction of different objects within their orbit around the star seems to be the biggest cause of eccentricity, but that also seems to be kind of the default. We've only discovered so many solar systems. Of course, we've only discovered a small fraction of the potential amount of solar systems that could be out there, but it does look like how even and circular the orbits in our solar system are, that might be the exception. As I've mentioned in previous videos, the Kepler Space Telescope discovered a lot of planets in this particular area, and the rest of the sky is probably just as full, but hasn't been studied in the same level of detail. With our solar system, there is a theory that our solar system formed looking in a very different way. So we'll pop out to the Solar System Observer and take a look down on the solar system, and I'll see if I can explain how this change is thought to have occurred. So this is the solar system as we see it today. We've got our big planets like Jupiter and Saturn, and then further out Uranus and Neptune, and then close into the center we have our rocky planets. Around a lot of other stars, a lot of exosolar systems, we see massive gassy planets quite close to their parent star. And there is a chance that that's where our Jupiter and Saturn formed, or at least our Jupiter. That Jupiter could have formed much closer to the sun and then migrated out to the orbit we see it in today. This is the great tack or grand tack theory, that Jupiter tacked its way further orbit, and the disturbance caused by Jupiter moving in that way forced the inner planets into more circular orbits. So there is a good chance that besides eccentricity being caused by the interaction of different objects, that the lack of eccentricity, this circularization of the orbits, may have also been caused by interactions between the massive planets and the smaller planets closer to the sun. So it is a very interesting question, what causes eccentricity, especially if highly eccentric orbits do turn out to be the default. If we discover enough other solar systems that we can really say that eccentricity is the rule rather than the exception, then we start facing a very different question. What causes that circularization? Why is our solar system the way it is? Next up, we are going to take a look at the moon. And of course, we take a look at the moon a lot on this channel. It is pretty much the most prominent thing in our sky. It's the thing that we always see almost every night. Only on the new moon and the nights close to the new moon will the moon be completely missing. Now, to make sure that everything looks good and stays visible, I'll also get rid of the orbital lines so they don't clutter up the sky too much. And we're going to take a look at the moon because I got a question about the shape of the moon. Now, hopefully I can do this fast enough. But if we take a look at the moon, we do always see the same side of the moon, the same face. But that doesn't mean we always see exactly the same parts of the moon. I'll see if I can location where it looks what I would call vertical, with the man on the moon or the football player standing up. I guess it's sideways if you look for the smiley face on the moon. But over the course of months, we can kind of see it happening there. The moon wobbles as it moves in and out. So as it goes from its closest point to its furthest point, apogee and perigee, we can see that it's almost rolling a little bit. So there's more of the south pole of the moon visible to us there. Oh, have to stay locked on the moon. And we're seeing slightly different bits of the moon when it's rolled around like this, a little bit more of that northern portion. So this rolling of the moon, lunar libration as it's called, I don't know where. Oh, I got rid of the moon by accident. There we go. This lunar libration, this rolling of the moon, it means we get to see more than 50% of the moon. People say that we see half of the moon and the other half is facing away from us. But really, we get to see about 65% of the moon and the rest is facing away from us. And this is one of the, I want to say, surefire ways of knowing that the moon is a ball and not a disk. Not only do we get to see the curve of the light as it shines on the planet, we can see the curved shape of the shadow, we can see those craters. But not only do we get to see this kind of effect, which highlights the spherical shape of the moon, over longer periods of time, we get to see this rolling, which shows us that there is more of the moon than the flat surface it can appear to be if you just look at it at one night. Now, of course, we have sent things to the moon. We've sent people to the moon. We've sent astronauts to the moon right in there, the Sea of Tranquility for Apollo 11 and the other Apollo missions in other areas. But if you want to make sure that the moon is spherical yourself, just looking at it with your own eyes or using your own homemade telescope, that is something you can do. And it is something you can do because the moon is spherical. You can check that it's spherical because it is. And the same is true for the Earth. And I bring this up due to the phrasing of the question, why do people think the moon is round when the Earth is flat? It is a great way to phrase the question because it starts the question with an assumption. It implies that the Earth is flat in its question, and that is a form of logical fallacy, kind of assuming your conclusion in the question, saying, well, if the Earth is flat, how is the moon round? We need to challenge the assumption that the Earth is flat. And of course, there's many ways to do that. Setting up a big stick in two different locations and looking at where the shadow falls at midday, you'll see that they fall into slightly different locations because of the angle at which the sun is shining at the Earth. You can also watch things drift over the horizon or, take a trip to a tall mountain and see how your view increases as you are able to see further around the curve from your higher elevation. Just like you can visibly see that the moon is spherical under the right conditions, you can also visibly see that the Earth is spherical as long as you do the right kinds of tests. So I do have one more question, and it's an excuse to bring up the constellations. And I show the constellations quite a lot on this channel. And I was asked the question, if we take a look at constellations, a question asked, is, given that these constellations mostly come from Greek and Roman mythology, are there constellations from other mythologies? The official 88 constellations that we use in modern astronomy, defined by the International Astronomical Union, these do come from Greek and Roman myths, but they are not the only ones. So although the official constellations draw from a pretty small set of the world's cultures, just that little bit of the Mediterranean and that particular point of time, there are way more constellations. There are lots of different constellations from different time periods, different parts of the world. I will get up the Chinese constellations if I can. Hopefully I will be able to bring them up. Different groups of constellations, some of them have art, some of them don't. So we can see here, rather than bringing up the images or the drawn pictures, what we have are different names for the stars. And these names come from the Chinese tradition of astronomy rather than the Western tradition of astronomy. I'll try to find some of the actual pictures. Culture, Indian Vedic, has pictures in it. And this shows something very interesting, I believe. Oh, that is not showing the pictures as I would have expected. Normally they show up as slightly different pictures. We can see there's a couple of the different pictures there, but it does show this same journey across the sky, the ecliptic, the same constellations. Not the same constellations, it's not these pictures, but the same part of the sky where the ancient Greeks put their ecliptic. The Indian Vedic stations of the moon and different locations of the planets, because the planets and the moon orbit in the same way no matter where you are, no matter what culture you come from. The Greeks weren't the only ones to prioritize that part of the sky and make a big deal about it. Various cultures saw that part of the sky was particularly useful for charting up. There's the Japanese stations of the moon. Maybe this will bring up the native images. It doesn't seem to be doing it. There are native images for all of these different cultures, but not all of them have been imported into the program. And it looks like some of them have changed. I know that, there we go. I know that the Inuit culture had its own pictures. So rather than having a bear for the plow or the Big Dipper, it is a reindeer or a caribou. And then there's these other pictures in the sky as well. A lot of these are bones. These different cultures are, well, they give different pictures in the sky, and a lot of them still name similar things. So this one is called flickering. So this star, what we would call Sirius in Western astronomy, is given its own name in Inuit astronomy as well, presumably because it's the brightest in the sky, and it's the brightest in the sky no matter which culture you come from. And we can see that there are loads more. I do really want to bring up the pictures, the images in the other cultures where they existed, because different people did draw different things in the sky. It's not just that they used a different language for the same things. Of course, if you went out and used your imagination, you might draw very different pictures in the sky. So here we go. These are Ojibwe constellations. And we can see some really beautiful things here. So presumably Thunderbird or one of the other sacred creatures in Ojibwe mythology. And we can see that they are still constellations, highlighting very specific stars at different parts of the picture, basing these shapes off the collections of stars that they see. But of course, it's very different to the ones that we use in Western astronomy, because it was a whole other culture that came up with them on their own. And these Ojibwe constellations, people came up with them before any contact with the Europeans and their Greek and Roman constellations. And the same is true for constellations coming from other parts of the world. For example, Samoa, it doesn't look like they are showing pictures, but it does come with some description of the names, so that's something at least. So to shorten up the answer, yes, there are constellations that come from other cultures, but they exist in their own context, their own group of pictures in the sky. So they're not usually mixed in with the constellations that we generally talk about in modern astronomy. Our Greek and Roman based constellations are one big group, and then of course there are all of these other groups coming from all of these other cultures around the world. Pretty much every culture is believed to have had their own set of constellations. Of course, not all of them have survived in detail, which is a bit of a pity, of course. But that does now bring me through all of the questions that were asked in my request for the Q&A for celebrating 100 subscribers. So if you would like to ask questions, I don't know when my next subscriber video will be, but there will be another one in the future. I won't be stopping this anytime soon. Hopefully I will keep climbing the subscriber milestones. Here we can see Mars just starting to appear early in the morning later this month. So moving into the future, Mars will be there. I hope that you enjoyed this video. If you'd like to see more of them, then please do like the video, subscribe to the YouTube channel, and check out Queeveen's content on Instagram and queeveenscontent.ie if you get the chance as well. So thank you, and hopefully I'll see you next time.